So it says, find the function value without using a calculator and refer to the following rules. So for this particular problem, they want us to input 4 without using a calculator. I'm going to split that up just so I can do it in my mind. So I have 5 squared times 5 squared because I know 5 squared and 5 squared gives me 5 to the 4th. So I have 25 times 25. And if I go off to the side and I multiply 25 times 25, I end up with 625. So I can say 5 to the 4th is equal to 625. Let's look at the next one. If I move this up, give me 1 second. There we go. Okay, if I move this up, I have now f of 4/3 equals 27 raised to the 4/3. As a reminder, we always want to take care of the denominator in the exponent first. So we want to think of this as 27 to the 1/3, and then afterwards I'll raise it to the 4th every single time. So what does this portion mean? It means what times itself 3 times gives us 27. 1 times 1 times 1, no, 2 times 2 times 2 is 8. 3 times 3 times 3 is 27. So this portion alone gives me 3, and then I'm going to evaluate it to the 4th power. So 3 times 3 times 3 times 3, I know 3 times 3 is 9, 3 times 3 is 9, and 9 times 9 is 81. So I could say f of 4/3 is equal to 81. Brandon, is that making sense?
Yes.
Okay. Let's look right now at number 3. So I'm going to input in -6. So I have 1/2 raised to the -6. And keep in mind, we want to distribute the -6 both to the 1 and to the 2. And so I have 1 to the -6 over 2 to the -6. This says I'm not happy. I'm going to go to the bottom, and now the exponent's happy. And likewise, the 2 isn't happy on the bottom. It goes to the top. Well, 1 times 1 times 1, 6 times is still 1. What is 2 to the 6th? Well, 2 times 2 times 2 is 8. And 8 times 8, because 2 times itself 3 times is 8, 2 times itself 3 times is 8, and 8 times 8 is 64. So this is equivalent to 64 over 1, which is just 64. So I could say f of 1/2 is equal to 64. Do you have any questions on 1 through 3?
No.
Okay, are you comfortable with those?
Yes.
Okay, do you want to try another one or move on to 4 and 5?
We can move on.
Okay, so 4 and 5, we're going to use this information here that's in this box, and we're going to state the domain, the range, identify the zeros, intercepts, and determine the asymptotes, and then do the end behavior. So let's look at the first one. The very first thing I see is when I look at this equation for number 4, it's y equals 1 times 3 to the x. And this is the value I'm going to look at. Because that value inside the parentheses is greater than 1, this is the graph that we're looking at right here. We're looking at this graph right here. It's increasing. So I'm going to start with the domain. It says the domain is going to be, and already tells us what the domain name is going to be. It's going to be -infinity to positive. I can see that right here. And I can see that the range is going to be 0 and above. Yes, can we add Damien to this call really quickly? Yes, Damien, we can. Let's figure out how to do this for Damien really quick. Give me 1 second here. That should add him. There we go. Damien, can you let me know if you're able to see the screen? Brianna, can you see Damien in the call?
Yes.
Or are you, he is in the call. Okay. Damien, can you hear me?
Yeah.
Okay, perfect. We're going to start with number 4 again. I can go back and show you 1 through 3, or you can watch the video. We're going to get started with number 4. So the first thing I do, give me 1 second here to get comfortable, and hold on 1 second. Okay. I'm going to rewrite number 4 is y equals 1 times 3 to the x. And so the very first thing I do is I look to see this value right here called the a value. Sometimes people call it b, but it's the value that we're raising to an exponent that's a variable. If that value is greater than 1, it looks like this graph. And so I'm going to start here with the domain and range. It already tells me what the domain and range is, regardless if it looks like the graph to the left or to the right. It has the exact same domain and range. So there's different ways I could say this. I could say the domain of f is equal to all real numbers, and the range of f is equal to y values such that y is greater than 0. So I've taken care of the domain and the range. Now let's go on to the zeros, the x-intercepts, and the y-intercepts. So it tells us that there's no x-intercepts. We have not had any transformations here where we've moved this thing up or down. So there's no x-intercepts, no zeros, but we do have a y-intercept of 0, 1. So we have a y-intercept of 0, 1. Okay, so I've taken care of that part. Now we are going to identify the asymptotes. So if I look at this graph down below without graphing this, we can see that we have a y-intercept right here, and that horizontal asymptote is going to correspond to the x-axis. So we have a horizontal, I'm going to abbreviate, horizontal asymptote of y equals 0. That means the graph that we have will never intersect or cross over the x-axis, which is y equals 0. Okay, and now let's talk about the end behavior. So I'm going to erase this just so I have a little more space to do this. But for the end behavior, I'm going to start off here by saying as x goes to negative infinity, we're going to describe what happens to the y. And as x goes to positive infinity, we're going to describe what happens to y or f of x. So we're going to fill in this box. Okay, so I know this is the graph I'm looking at for number 4. Why? Because this value is greater than 1. Okay, so here we go. As I go to the far left, it's going to get closer and closer to that asymptote of 0. It never touches it, but it approaches it. It gets closer and closer as it moves to the left. Now, as I go to the right, as I move to the right, it's increasing upwards. It never stops going up. That is number 4. Let's take a look at number 5. Now, what's different about number 5, if I move this up, what's different about number 5 is that value right here is not greater than 1, which means I'm going to need to rely on my second graph to the right. So as it goes from left to right, it's actually decreasing. So we have the exact same domain, whether I write it in interval notation like you see here, and the exact same range, or we could have done something like this. The domain of f equals all real numbers, and the range of f is all y values such that y is greater than 0. So I've done the domain and the range. If I come up above, let's see, what other things was I supposed to answer here? I need to do the intercepts and the asymptotes. Let me bring this back down. Okay, it already says there's no x-intercepts. Doesn't matter which graph we're looking at, there's no x-intercepts because they both have the same asymptote, that horizontal asymptote that aligns with the x-axis, and they both have this y-intercept of 0, 1. We can see that 0, 1 in both places. All right, next thing is we are going to identify the asymptotes. We have the exact same asymptote, y equals 0. And the last thing is going to be the end behavior. So let me do that over here. As x goes to negative infinity and as x goes to positive infinity. And I probably should have put f of x, but f of x and y are the same thing. As the function goes to the far left, so as the function goes way over here to the far left, we can look up, we can see the graph is going upwards or it's increasing. Now, as I go to the very far right, it's getting closer and closer and closer to the x-axis. So it's getting closer and closer to where y equals 0. It's approaching it, but it'll never actually touch it. Damien and Brianna, as I go through it, does that make any sense? You're welcome to say no.
Yes.
Yeah, it makes sense.
Okay, let's look at the next one. So we're going to use the rules of exponents to the right. And so as I look here, I want to go, okay, what is e? And I'm going to plug in 8 for the x. So e to the 8th divided by e to the 3rd. And so when we have the exact same base, the base stays the same, and we're going to subtract the exponents, and I get e to the 5th. Let's look right now at number 7. Am I going too fast?
No.
Okay. Let's look at number 7. So number 7 here, we are going to first take f to the third. So I'm going to plug in 2 to the third, and then I want to multiply it by 2. Let's plug into the second. So I'm replacing this variable x with 3, then multiplying the function after I replace it with 2. Well, when you have the exact same base, you keep the base the same, and you add the exponents. So I have 2 raised to the 3 plus 2 is 5. So I'm going to take 2 times 2 times 2 times 2 times 2 5 times, and I end up with an answer of 32. Now, you may have wondered, why did you do 32 for this one, but then up above for this particular problem, you left it as e to the 5th. Well, I know that e is Euler's number, and it does equate to a decimal form, but without using a calculator, I could not evaluate that. So I just left it in simplified form. Let's look at number 8. Exact same concept here. I'm going to substitute in this -1. So I have 7 over 8 raised to the -1, and then I need to distribute to both the 7 and to the 8. So 7 to the -1 over 8 to the -1. The 7 isn't happy. It's going to drop down to the bottom, and now it's happy. The 8 isn't happy. It's going to go to the top. 8 to the first is 8. 7 to the first is 7. It can't be simplified any further. Let's look at number 9. Looking at number 9. So suppose this is the function, and it says if e to the u is equal to e to the 21st, then what is u? So that's the same concept as saying this. If I said 3 to the second is equal to 3 to the x, well, what is x? And in this form, we can see x equals 2, the same concept. Then u is equal to 21.